evaluating piecewise-defined functions for given values.
We will going to find the value of x in each given function. Identify whether the function is increasing or decreasing, and the interval of each function, whether increasing or decreasing. So, let's start and evaluate each functions. Example number 1. Let f of x be 1 plus x if x is less than 2. Let f of x be x squared minus 2 if negative 2 is less than or equal x. Let f of x, x plus 1 if x greater than or equal to.
In each particular value, there's only one formula is going to use. So we start at the x value less than 2. We use the formula 1 plus x. If we will start the value of x greater than or equal to negative 2, we will use the formula x squared minus 2. And if we start the value of x greater than 2, we will use the formula x plus 1. A. Evaluate f of negative 1, f of 2, and f of 3. So if we want, for example, to evaluate f of negative 1, we will look for what interval negative 1 belongs to. We can use these two values because negative 1 belongs to this interval and this interval also. Well, negative 1 is less than 2, so that we will use the 1 plus x formula. And if we'll evaluate f of 2, look again to what interval f of 2 belongs. Obviously, f of 2 is not greater than 2, so we will use this interval instead. And if we evaluate f of 3, we will use this interval for 3 is greater than 2.
And we're going to evaluate f of negative 1 to 1 plus x. First, substitute the value of negative 1 to x. F of negative 1, substitute to x, we will get 1 plus negative 1. Perform the operation addition. We will come up to 0 as an answer. So, f of negative 1 equals 0. We have now the value of f of negative 1. Next, I'll evaluate f of 2 using the formula x squared minus 2. Substitute the value of 2 to x. f of 2 substitute to x squared, we will get 2 squared minus 2. Then, subtract the 4 minus 2. We will come up to 2 as an answer. In the last function, I'll evaluate f of 3 using the formula x plus 1. Substitute again the value of 3 to x. f of 3 substitute to x, we will get 3 plus 1. We will come up to 4 as an answer.
After finding the values of each function using f of negative 1, f of 2, and f of 3, I'm going to find over what interval is the function decreasing. So, let's start at negative 2 less than equal x with the formula x squared minus 2. Maybe we can use some points. Try to use 1, 2, and 3 as x coordinate. Then, substitute the value of 1 to x squared minus 2. We will get negative 1. Next, Substitute the value of 2 to x squared minus 2. We will get 2. And last, substitute the value of 3 to x squared minus 2. We will get 7. Notice that as x coordinate increase, the y coordinate increase as well. So, it is increased over that interval.
So let's move on and try another formula. For x greater than 2, the formula is x plus 1. Again, think of numbers that is greater than 2 and then plot some points. Try using 3, 4, and 5 as our x coordinates. Then, substitute 3 to x plus 1, we're going to have 4. Substitute 4 to x plus 1, we're going to have 5. And substitute 5 to x plus 1, we're going to have 6. Notice that as x coordinates increase, the y coordinates also increasing. So, it is not decreasing over that interval.
Let's try the last formula, 1 plus x. For x less than 2, think a value that when substituted to the formula 1 plus x, the answer will be less than 2. Let's plot some points to deeply understand. Let's try 0, negative 1, negative 2 as your x coordinates. If you plug in 0, you will come up with 1 as an answer. If you substitute negative 1 to x, then the answer is 0. If you substitute negative 2 to the x, then the answer is negative 1. This interval of x coordinates from 0 to negative infinity, the y coordinates decreasing, which means it is decreasing over that interval. We have now the answer for letter B.
After finding the values of each function, identifying whether increasing or decreasing, and the interval, let's move on to our second example. Example number 2. Let f of x be x squared if 1 is less than x. Let f of x be 10 minus x if x is greater than 2 but less than 6. Let's try to evaluate each function using f of 5 and f of 2. The value of f of 5 will be going to use in the formula 10 minus x for 5 is greater than 2 but less than 6. Let's evaluate now. F of 5 equals to 10 minus x. Substitute 5 to our x. We're going to have 10 minus 5. Subtract 10 minus 5. We have now 5 as an answer. Let us find now in over what interval is a function increasing. Let us try first this formula, which is 10 minus x if x is greater than 2 but less than 6. Think again of numbers that belongs to the interval x greater than 6 but less than 2. Let us now plot some points. Using x and y coordinates, think of numbers that is greater than 2 but less than 6. Let's try 3, 4, and 5. Substitute 3 to this formula, we're going to have 7. Substitute 4, we have now 6. substitute 5, we have now 5. So, notice that as x coordinates increasing, the values of y coordinates are decreasing. So, in this function, it is decreasing over that interval.
Let's try the second formula. Knowing the value of f of 2 is greater than 1, we will be going to use the x squared formula. If we substitute 2 to x squared, then if we squared 2, the answer will be 4. Let us find out what interval is the function increasing by using the second formula, x squared, if 1 less than x. Think of a number that when substitute to x, the answer will be greater than 1. Let's plot some points now. Let's use the numbers 4, 5, and 6 as our x coordinates. If we substitute 4 to x, then we will get 16 as an answer. If we use 5 to substitute to x, then we will get 25. And if we substitute 6 to x squared, then the answer will be 36. Notice that as x coordinates increasing, y coordinates also increasing, which means that this function is increasing over that interval. So that our answer in this example is x squared if 1 is less than x.